Okay, all right. So, what I was listening to, you can see my screen, right? This
Yes,
journal board, right?
yes, yes, it is visible.
Okay. So, what I was suggesting, I took the example of that batches. Let's suppose you have, let's say, batch one, okay, batch two, batch three, and batch four. Okay. So what you have done, suppose whatever the observations you had, right? You divided in four kind of batches with some similarity. Let's say uh, you can do with uh, like in terms of watt, like 7 watt, 8 watt, something like that. Okay, some size of the bulb or company of the bulb or something like. So you have divided in k different classes, right? Are you get some four different batches? Okay, so that is something I'm trying to explain here. So what you can see, right? So let's say you have observations y11, y12 up to y1 and 1. Okay, then y21, y22 up to y2 and 2, y31, y32 up to y 3 and 3, or yeah, and 1 and similarly. So suppose in this you took n1 sample, n2, n3, and n4. Okay, and summation of these all ni should be your total number of sample, right? This is something we have to keep in mind. Okay, now so what you will do, what will be your hypothesis actually? So you will see whether all batches are equal something like mu1 means, so mean for the first batches means the four batches of electric bulbs are homogeneous, right? Or something like that you will see. So okay, so you are talking about the variation. See, so you see, you have divided, you made the batches, right, with some criteria. All right, these four batches. Then you must be interested to know, is there any variations within this particular group for each group, right? Let's say for first batch, for second batch, for third batch, and for fourth batch, right? So that's why we are talking about ss w means sum of squares, okay, within group. Okay, are you getting my point? So within group we are first of all talking. See, we made some four batches, but we should be interested. Okay, first of all, okay, what I made the hypothesis, all all mu I should be equal, right? That means all four batches of your electric lamps are homogeneous, right? So homogeneous means what? You will try to take those observations for which it I mean for which in each batches variations are less, or those observations are homogeneous. Yes or no? Homogeneous means variations will be less. Are you getting my point?
Yes, sir.
Okay.
But a quick question. When we are taking N1,
Hmm.
like the N1 sample from
Hmm.
first batch,
Hmm.
uh, our whole population will be the Y1s, and we are choosing N1 of those, right? Is my understanding
No, no,
correct?
no, no. Okay, okay. Suppose you have total n observations. Okay, okay. Based on those n observations, what you done? You made a batch of n1, n2, n3, n4. So these yi's will represent the observation. So y1 is first observation of first batch, second observation of first batch, n1th observation of first batch. That is the meaning. Okay.
Got it. Got
Got
it.
it? Okay. So you will check whether you to check variations within that group. So if you see the formula, right? So normally we are writing the formula. I think I'll try. So formula, let's say I have k batches, right? And I will see what is the uh, like number of samples in each. So what I will see, yij minus y bar I dot whole square. So what we are interested here, if you observe this formula carefully, so actually this y bar I dot means 1 upon ni summation of j is equal to ni yij. So what we are taking? Can you tell me? What do you understand by this formula? Y bar I naught.
For first batch, we are
Basically, we are taking average of the observation for ith batch, right? Yes or no?
ith
Yes.
batch, as in
So we have 4 batch, right?
yes,
So y bar I dot means we are taking you can see y 1 upon see okay, if I will write y bar 1 dot means 1 upon n1 number of observation and addition of all the observations, right? Y11, y12 us up to y1 n1. That is the meaning. Are you getting?
yes, sir.
Okay.
Got it.
Now what we are doing, we are taking 1 second. Yeah. So what you are doing? So we calculated mean of this batch y bar 1 dot, y bar 2 dot, y bar 3 dot, y bar 4 dot. Yes or no?
Yes,
Right. Now what we are doing now? We are taking the like we are subtracting this each observation with this and taking the square. Correct.
yes, sir.
Correct. That is something we are doing here, right?
Right.
SHW. You can see the formula Yij minus y bar 1 dot. We are talking about ith batch. All right. So what similarly what we'll do for all batches. So here we are interested what is the sum of variations within the group. Okay. Now you might be interested, is there variations between group? That might be your question, right? Are you getting? So within group, you have calculated. What about between group, right? Like this is the okay. This is the first batch. Whether is there variation from this batch to this batch or from this batch to this batch? Okay. So if you see, so second variations we are interested to find sum of a square. SHB means between groups. So if you see this formula, summation I is equal to 1 to k. K means number of batches or treatments. Ni, and here we'll do y bar I dot minus y bar double dot. So if you see this formula carefully, right? So y bar double dot means total mean. Okay. Summation I, summation j, yij. So this represents, so here what we are taking, we had 4 batches, right? Batch 1, I'm writing B2 for batch 3, B3 for batch 4. So for batch 1, what was the average? Y bar 1 dot, Y bar 2 dot, Y bar 3 dot, Y bar 4 dot. See, this is the one, Y bar 1 dot is the one, is the value which is going to represent the whole thing for batch 1. Yes or no?
Yes, sir.
Correct. Y bar 2 dot will represent the I mean it will represent the central value for batch 2. Similarly y bar 3 dot, y bar 4 dot. So what we are taking here, we are taking the I mean deviation from total mean, right? So this will give you basically idea of between groups. Are you getting? See, you made 4 groups. You might be interested to calculate variations, whether is there any variations within group. And since you have 4 groups, so you will be interested to calculate the variations between groups also. And if you add these 2 groups, right? I mean, these 2 variations, this within and between, you will get the total sum of squares. Okay. So if you
Yes,
see
sir.
the
Got it.
formula total sum of square, if you add these 2 formula, right, then some product term will be cancelled out. So you will get at the end summation I is equal to 1 to k, summation j is equal to 1 to ni yij minus y bar double dot square. So see, there is very simple trick, or you can say trick or something, try to understand. So here we are talking about total sum of square, right? So if you see, we have observations minus total mean, right? Okay.
Yes, sir.
Okay. I mean, some sort of idea is clear or not?
One quick question I had.
Hmm.
You can go to the screen once more.
Okay, fine.
And SSW part in the formula of SSW. So we are calculating the variance within the group. So for
Correct.
each yi dot, like let's say y1 dot, which is first group, we are calculating variance to find the homogeneity. Like we want everything to be similar.
Similar, yeah.
But then why are we summing over I of 1 to k? Like we're taking all of the groups, right?
No. See, you will check within group for all group, yeah. it's like
Okay.
see, you will check for what is the sum of square within group for all batches. Okay, that will something you will try to, it should be some minimum, as minimum you can. Okay,
Okay.
so this is something involves, I mean those things we are not uh, involved, I mean those thing is not involved here actually. One second. So that is called something, maybe you heard anytime, stratified sampling. Okay, so in stratified sampling what we are doing, suppose I have a population of n size. Okay, then what I will do, I will divide this population in some k stratas called strata each. So in n1 what we'll do, so in each strata I will take some samples of n1 size. Okay, then here n2 size till nk size, and then we'll perform. Then what normally we are trying to see, this strata or this group or this class, you can say, we are trying to make as I mean homogeneous as much we can take. So homogeneous means there should be less variability within that group or within that class. Okay, so if you see in one way classification, right, so we are doing the classification, I mean there is only one parameter to make the classification. Like I took the example of in the last class, if you can remember that, breed of cows, right? Okay, so suppose you have some three breed of cows, and you have divided breed of cows based on this different uh, breeds. Then you will see whether impact of or yield of milk for each these things, right? So that is something what you have done here. You have divided your data set, or you have classified your data set based on only one factor. Okay, sometimes you will see when you will study about two-way classification and all, so we will be having two different factor. Okay, let's say here breed of cows, and another factor will be, let's say, type of food which we are giving to cows. Okay, so accordingly we'll decide our treatments and make the classes. I mean, okay, so is this all right? Okay, so one more thing I can suggest to you. So these kind of things is kind of important. Okay, this total sum of square, sum of uh, variation within group, between group and all. Okay, all right.
Yes.
Okay, yeah. Yes, Hari.
Sir, I think in SSB part we are
Hmm.
like multiplying number of observation
Yeah, this is
before.
the same thing. Yeah, it's the same thing. That's not a problem. I wrote both summation, right? So
Yeah,
since j term is not there, right, so it will be ni. That's not a problem. Okay.
yeah. But sir, my
Hmm.
doubt is that like whenever we are calculating variance, we are
Hmm.
usually dividing the thing by n number of observation. But in this SSB, why are we multiplying this number of observation in this squared difference?
Can you repeat?
Like
Hmm.
in simple form,
Hmm.
whenever we are seeing the formula for variance
Hmm.
of anything,
Hmm.
we are generally dividing the square difference by n, by number of observation.
Hmm.
But in this part, SSB part, why we are multiplying that
Okay.
ni?
Okay. Okay. First of all, let me clear. It's you are okay. Let me write one formula. That much. Okay. Suppose I'm right. I'm going to find variance of ith group. Okay. Okay, so
Yeah,
how I can write this one? So simply I will write 1 upon ni minus 1, right?
yeah,
Summation j is equal to 1 to ni yij minus y bar I dot, right? Correct.
yeah, right.
So what is this? This is nothing but it's your unbiased estimate, right? I mean unbiased estimate for
Yeah.
population variance. I'm not talking about. Okay, let's not go there. Okay, now what if you see this formula, sum of squares? So here I'm talking about sum of squares within group. Okay,
Mm.
so this normally SHW will write it. So here if you see what we are doing, okay, what you will do here, okay, just think, see, we have to do for every group,
Yeah,
correct? Yes or no?
yeah, yes,
So
yes.
how many groups are, okay, first of all I have to include this terminology, right?
Mm.
Okay, so if you add for all groups, what it should be, what should be your next thing?
like we will simply add this squared thing for every group.
That's all right.
Hmm. Yes.
That is something we are doing. Okay, maybe okay, I will write some one equation, maybe that will help you for all of you. Okay, so normally we are writing the equation. Okay, let me go that that thing we haven't discussed here, but I will give you the idea. Okay, so what is the one way model for one way classification? Like it's let me write yij equal to mu plus alpha I
Mu y.
plus uh, yeah, alpha I or mu I, that's not a problem. Okay, epsilon ij. Okay, so here mu represents the overall effect, right? And alpha I will represent the effect for the ith treatment, correct?
Yeah.
Okay, now normally what we are doing, maybe you can recall from machine learning concepts. So what we have to do for a model, suppose I want to estimate this mu I, sorry, alpha I and mu, then what should I do?
Sorry.
Suppose I have to estimate this alpha I or mu, then what is our approach generally, what we are following?
We are finding the SSE of that alpha I.
Yeah, basically we are trying to calculate this. Uh, we have to minimize the error, right? Something, correct?
Minimize it.
Correct.
Yes. Yes.
So if you solve this, right? So if you will do summation I, summation j, yij minus mu I minus alpha I square, yes or no?
Yeah.
So
Yes.
if I'm not going to do the all the derivation with respect to mu and derivation with respect to alpha I will tell you what is will get. If you will differentiate with respect to mu and will equate to 0, I will get mu hat as a y bar double dot. Okay, and anyway I told you mu will represent the overall mean effect, right?
Okay.
Okay, so similarly, can you guess what should be the value of alpha I hat?
Alpha I hat, it will be equal to the
Okay, alpha I represent the effect for the ith treatment.
I to mu I.
Y bar I dot
No, see,
minus y bar dot dot.
yeah, so actually you have to calculate. So it will be y bar I dot, right, minus y bar double dot. Okay, so I'm not going to do that. Okay, you got how you can get these values, right? Okay, basically you have to differentiate this yij with respect to mu, then you will equate with 0, then you will get this thing, and this yij with respect to alpha I, then equate to 0 and you will get this. Okay, this is alpha I hat actually. Okay, now what will be your model now?
Y bar I dot plus y
So
bar I
basically
dot
my
minus y bar.
model will become yij, right, y bar double dot plus y bar I dot minus y bar double dot, yes or
Yeah.
no,
Yeah.
plus
Epsilon.
Yij minus y bar
okay, what
I.
about epsilon ij? What should I write?
Yij minus y bar I
That
dot.
follow normal distribution, no sir?
Yeah, that follows normal distribution. What should I write here? To okay, can you think about like both sides should be equal?
As in both sides should be.
Yij minus y bar I dot.
Correct. So at the place of residual, I can write yij minus y bar I dot or not. Just think or tell me whether it is correct or not. Correct.
That is the error term.
That is the error term, right?
Okay. Okay.
Okay, now it is fine. Okay, now what I can do? Can I do yij minus y bar double dot? Okay, 1 second. Yeah. Then y bar I dot minus y bar double dot plus yij minus y bar I dot. Yes or no? So far, so good. Everyone is getting right these 2 points.
Yeah.
Yes, son. Okay.
Mm.
Now, correct me. Can I do these things if I will do the addition for all I and for all j, right? Okay, and I will take square. Okay, same thing for both side. So it will be y bar I dot minus y bar double dot plus yij minus y bar I dot whole square. I can do this, yes or no?
Yeah.
Okay,
Yeah.
now. So if you will solve this, just consider this as a as a b. So it will be a plus b whole square, right?
Just one thing, sir, here that y, the first term is y bar I dot, right?
Yeah, y bar I dot.
And
This
the
one.
last term is also, yeah, last term is also y bar I dot.
Yes.
So that will cancel out now. Minus.
One second, one second, one second. I think I made a mistake. Made a mistake. One second. One second. Yeah, yeah. It should be actually y bar.
Epsilon is over all the group or for single group?
One second. Let me check. I think it should be yij minus y bar double dot, and then y bar I dot minus y bar double dot plus yij. No, I don't think it should be yij. Should be y bar I dot, right? I think. One second, one second, one second, one second. So it will get cancel out. It will get cancel out. All right. So yij minus y bar double dot plus yi bar I dot minus y bar double dot plus yij minus.
No, I think this is right. Because A would be the sum of squares between, and then B would be the within, right?
Once yij minus. Yeah, I think it's correct, right? Yeah, I think it's correct. Okay, okay. Oh, that's correct. Okay, I will tell you what we are doing. Okay, yes, correct. Okay, so what should I write? I can write summation I is equal to 1 to k summation j. I think so, some issue with this journal board. I'm not sure why. Okay, let me write here. This is fine, right? Okay, so summation I is equal to 1 to k, summation j is equal to 1 to ni. So I had yij minus y bar double dot square, right? Then I had summation I, summation j, and yij minus y bar I dot plus y bar I dot minus y bar double dot whole square. So what I can write these things on the right hand side, I will write summation I, double summation, second summation for j. So can I write yij minus y bar I dot whole square plus double summation y bar I dot minus y bar double dot whole square? Yes or no? Are you getting? So I splitted this as a and this as a b. I can write these two, right? Yes or no? Then what should be the next term? It should be 2 times of double summation product of these two. Yes or no?
Yes.
Okay. So basically, you will, if you will solve this, right? So one product, I mean summation of yij. Basically, there will be one term summation j is equal to 1 to ni. Okay, yij minus y bar I dot. If you solve this, it will be 0. Okay, so this actually cross product term will be 0. So what we are getting here? So we'll get from here summation I, summation j, yij minus y bar double dot square equal to summation I, summation j, yij minus y bar I dot square plus summation I, and since there is no term related to j, I will simply write ni y bar I dot minus y bar double dot square. So what, can you tell me something which you can observe from here? What is this?
Total sum of square.
Total sum of square, right? What is this?
SSW.
Okay, this is within group, right? And this is
SSB.
okay. Now the formula came from here actually.
I see. Thank you.
Okay, yeah. Just give me a second. Let me connect my laptop to the charging point. Okay, so I think in week 3, main concept is this one-way classification and how to represent our model in matrix form and all, right? Basic concept, I think. Okay? Not more than that.
Sir, one thing is that how important is it to understand the degrees of freedom for this course? Like, because
Actually, degrees of freedom. Okay, so do you have any idea like what is the degree of freedom? What it tells actually?
actually not today, me, Hari, and Ananya, we were discussing separately that
Mm-hmm.
if we know, and please let me know if you guys know. But none of us know, so we decided to ask you instead.
Okay. Okay, so degree of freedom is nothing but actually suppose if you see the term, right, degree of freedom. So freedom is something independence, right?
Yeah.
Okay. So let's say I will tell you with some very example, like okay, so independence means normally in degree of freedom what we are checking, like what is the number of independent parameters or variables that we are going to define. For example, to make a statistic, for example, in variance formula. Okay, let's say, have you seen that t statistics formula, right? Okay, so what is the formula for
Yeah,
t
yeah.
statistics? X bar minus mu divided by s by square root of n, correct? It
Yes.
will follow t n minus 1, right? So n minus 1 degrees of freedom. So I told you degrees of freedom, what number of independent parameters that define our statistics. Now if you see while calculating the t statistics, there is one assumption, we are going to use t statistics when population standard deviation is unknown to us, correct?
Okay.
And just tell me whether do you know this or not. See, we can use z test and t test to test the mean of any sample, right?
Mm-hmm.
Yes.
Okay, so for z test, what is the formula? X bar minus mu divided by sigma by root n. Okay, okay, let me share my screen. Okay, can you see this? So what we are using, normally we are using z equal to x bar minus mu divided by sigma by root n in case of z statistics, right? In
Yeah.
case of t statistics, when we will use, so t statistics nothing but x bar minus mu divided by s by root n, right? And this will follow, I told you, t n minus 1. So when we are using t statistics, when this population variance or population standard deviation is unknown,
Unknown.
right? So if population standard deviation is unknown, that's why we are using an estimate of this sample variance, correct? Actually this expectation of s square is equal to sigma square. Okay, so now
Yes.
if you
Yes.
see, I told you, so degree of freedom is what? Number of independent parameters, okay, which basically helps to form our statistics. Okay, so now if you see, now there is one dependency on this sample variance, right? We have to estimate this I mean we have to calculate this sample variance, right? There is one dependency, rest are independent, correct? So that's why we are subtracting one, because there is one dependency for your regarding your this sample variance term. Okay, because we don't know the variance, we have to estimate, so there is one dependency. Okay, so this is the one key idea behind degree of freedom. So you can think number of independent observations, sorry, not observations, parameters or variables which defines our statistics. Maybe you have seen that one form of t statistics from week 2, we are taking the ratio of standard normal variate and dividing the square root of chi-square variate divided by degree of freedom, right?
Yes.
Correct. So in that case, there is no dependency. We have separate standard normal variate and separate chi-square variate, and we are taking basically square root of those things. So that will follow Tn. Okay. While this formula will follow Tn minus 1. Are you getting some sort of idea? Yes, Sahiti, right? Pronouncing the correct.
Yeah.
Yeah,
So it would be just like the number of independent um, parameters before you have to put a constraint on
correct,
something.
correct, correct,
Uh,
correct. Basically, which will help to form our statistic.
okay, okay.
Okay.
So
Yeah.
if you like, I read this somewhere where if you were to add up, like, say, 10 numbers and they had to equal 100, then you can only choose 9 numbers before the 10th one has to be equal
Correct,
to
correct,
something.
correct,
Okay,
correct, correct. That's correct.
got it.
Okay.
Thank you.
Yeah. Okay. All right. Yeah. Is there anything else? So, okay, how many of you covered the all the content of week 3? Is this every lectures you have seen, or is it pending or going on?
It's still going on for me. I
Okay.
covered half of it about.
Okay. All right. All right. That's not almost completed. Watched. Okay. Fine. Okay. Is there anything else want to discuss? Want to ask? Or
Sir,
Sir,
if you don't mind, can you tell us how the quiz will be structured in terms of the questions and stuff?
questions? I mean, you're talking about quizzes or all assignments in terms of.
I'm talking about the quizzes because we have subjective assignments.
So
In that,
subject, okay, there will be subjective assignments. So there will be some questions where you have to, let's say, calculate the things. For example, suppose we can give us some data, and I asked calculate the SSW. Okay, then you have to calculate that sum of square within group or sum square between group, something like that. Don't worry about this formula. We'll give the formula also, and there will be questions. Suppose. Basic thing related to R, okay, or else I can give you some output related to R, and I can ask something from what you can infer from output, something like that, okay. Or there will not be something you have to write a code of some 6 to 7 lines in on your I mean during your quizzes. There suppose there might be a question, but let's say suppose I ask what how will you uh, let's say anything, how will you find the first 6 rows of from the data, then what you will do, what kind of command you will write? Yeah, I'm asking actually. Anyone? Suppose I ask you to find first 6 rows of any data set. Yeah, head. Yeah, correct, Manasita. So if there will be a question related to R, so this kind of very basic thing, at least for your quiz one, and for quiz two and end term, is there will not be anything something like that. I gave you a line and you have to write the code. Let's say 6 7 line code. That will not be the case there. There might be question related to R, but suppose I gave the output from the R, okay, and you have I asked what is the, let's say, uh, what will the value of T statistics, or what is the value of slope from that output, what is the value of intercept from output. So main thing is to ask such kind of questions, whether you are able to interpret something from outputs or not. Okay, sometimes we simply do the coding, we don't focus on the code, sorry, output, but we have to do like that, okay. But all questions will not be based on R, but yeah, some subjective will be there. So for some, let's say, some, there might be some no proof or something like that, okay, one or two proof or some questions which you have to calculate it. And then don't worry about this difficult formula and all, this all basic formula we will give you. The key thing is you have to uh, identify which formula you have to use, and you have to use that formula to solve that particular question. Okay, is this? I'm hoping I gave the answer for it.
Yes,
Okay,
sir. Thank
okay,
you.
okay, all right.
So
Okay.
one more thing is
Hmm.
that for the PDF that we create,
Hmm, hmm, hmm.
there we have to explain what we are doing, or we have to write the code as well.
uh, if you have written code and you have interpreted your answer, that will be good actually. You can do in
Okay.
separate way also. If you, okay, one thing, you have to submit your code file, right, and another is report file. All
Yeah.
right.
Yeah.
So sometimes what people do, they simply write all codes in code file and all outputs, or like like they simply interpret the things in a report file. That's okay, but if you have written the code and below that code explanation and all, that is easier for us to check the assignment. That is the one thing.
Understood. Understood.
Okay, so I think, are you aware about that R markdown?
No, no, actually, that was my next question.
Okay, no worries. No, I think Hari, you were there, right? If I'm not wrong.
Yeah, yes.
Okay, so you can explain to Abhishek. So that is helpful actually to write the code, and below that code explanation of that code, or according to the question you can write the things.
Yeah, and sir,
Yeah.
what is the concept behind this one-way classification, maybe two-way classification? The model which we are studying in week three.
No, actually, Hari, see, suppose you have been given the data, right? So you want to do, suppose I took that example, right? So let's say a breed of cows, right? So suppose there are some four different breed of cows. Okay, you want to see the yield on milk, right? Okay,
Hmm.
then it's good to, you have divided your, you have classified your data set, right? So it means, suppose for, so you might be interested to know what is the yield on the milk for the, let's say, for first batch, I mean first kind of breed, then
Yeah.
second kind of breed, then for the third kind of breed, and then fourth kind of breed, and so on, whatever the number of batches are there. All right. So
Hmm.
that is something you will see in two-way classification and all. So it's not like that always you will get very simple data, one independent and one yes, three taste of homogeneity, because if you have batches, let's say batch 1, batch 2, batch 3, so you will be interested to know, like all batches should be homogeneous as much as you can. Okay, so that's why we are check normally we are checking that variability within the group. Okay, so we'll try to, I mean, normally that variance within the group should be minimum, because if we are going to classify based on batches, then it should be minimum, right? I mean, in batch first, all the cows should be from the same breed. Okay, if they are from the same breed, then you might expect the yield on milk should be approximately same. Okay, that is the thing, very general thing. Are you getting idea, right, what I'm trying to say?
Yes,
Okay.
so it is kind of similar to what we do with that last year.
Yeah, you can say, but we are not doing clustering separately. But you can say that's not.
Can we say that we're testing if they are coming from the same population?
Sorry, could you repeat?
Can we say that we are testing if the samples are coming from the same population?
No, anyway, sample are from the same population. We'll check all four batches are homogeneous or not. Okay, suppose you have batch 1, batch 2, batch 3, batch 4. You will check your null hypothesis will be mu1 equal to mu2 equal to mu3 equal to mu4. Means whether all batches are homogeneous or not. That will be your hypothesis.
So if they're not homogeneous, then they're not from the same normal population,
Yeah,
right?
that is the error, right? That error,
Okay.
so that error may occur, right? So if all batches are not homogeneous, then accordingly you will do some different test. Okay.
Okay, got it.
Okay,
Thank
yeah.
you.
Yeah. Okay, is there anything else? No.
Sir,
Hmm.
when we say about linear models,
Hmm.
so should this linear models be linear in parameters or should it be linear in what we say variables, or it should be linear in both parameters and variables?
No, no. Can you first of all you can you differentiate between variable and parameter? I talking about beta not beta one and x1 x2.
Yeah, yes,
Okay,
parameters.
okay. How will write the very simple linear model? You should write.
Like if there is one dependent variable, then we
Mhm.
can write it as y is equal to beta naught plus beta 1 x x1 plus beta 2 x2 like this.
Hmm. Okay.
So this is linear in
Correct.
linear
If
model.
yeah, if you'll write beta naught plus beta one x square, then
I think it is linear in parameter. I'm confused actually.
okay, okay, okay. Just think if okay, what do you, okay? I will suggest you one more thing. Just go on R or collab file, whatever you are interested. Just write for y and just write for x. Okay, beta naught plus beta one x square. You can simulate some values for x. Okay, and x square. I mean x. Then make it as y equal to let's say 5 plus 2 times of x square plus some error, right? And then you can write another beta naught plus beta 1x plus epsilon and see the difference between both curve.
Okay.
Okay, you will get whether what kind of graph you are getting. Okay, so you can simply do, let's say you are generating simulating y from normal distribution some values and then x, and then you can simply form your y as a let's say 50 plus 2 times of x square plus your error. Okay, then just plot x comma y. Okay, then just see what kind of graph you are getting. Now okay, I can tell you right now, so what I'm suggesting, just do that and see, you'll get idea what kind of curve you are getting. Okay,
Okay, we'll do
okay,
this.
yeah, just check. Anyway, we have group, you can ask, I will be there. Okay, I'm just giving you as a exercise so that you can get idea from your own. Okay,
Okay,
all right, yeah.
I will do this.
Oh yeah, yeah, thanks. Okay, then is there anything else or you can wind up then? No, let me anyway keep paste this YouTube link on the calendar. You can watch it later. Okay, so after week 3, okay, uh, we'll give you mock, right? So that you can attempt and you will get some idea uh, for your quizzes. Okay, after week 3 most probably. Anyway, your quiz will be based on week 4. So after week 3 we'll give you. Okay, will that work to all of you? Okay,
Yeah, all right.
okay, okay. Then if we don't have anything, then we can